Hello everyone, I'm Sebastian Y and this is Managerial Economics. In this video I'm going to talk a little bit about finitely repeated games. In the previous two videos we focused on infinitely repeated games, that is, games that are repeated without end. They continue on forever. This allowed the Grim Trigger strategy to carry an effective punishment for not cooperating because that punishment could be repeated forever. We're now going to think about finitely repeated games with a known final period. This means the stage game, that could be a prisoner's dilemma, a Cournot, or anything, is repeated for a predetermined number of periods. After that period, no more payoffs are collected. While the Grim Trigger strategy can sustain collusion in infinitely repeated games, it cannot do so in a finitely repeated game like this. Suppose we have a pricing game like the one we talked about in an earlier video that goes on from t equals 0, t equals 1, t equals 2, and t equals 3. And after t equals 3, the game is done and these firms don't interact with each other ever again. Let's suppose the firms try to use the Grim Trigger strategy, just like we did before, to get a Nash equilibrium where they cooperate. Remember that Grim Trigger says that in any of these future time periods, t equals 1, 2, or 3 in this case, if the other firm ever undercut them in the past, they're going to undercut now. Let's go all the way to the end. The reason anybody cooperates is the threat of future punishment. When we get all the way to t equals 3, there is no future to be punished in. And so what incentive do the firms have to continue trying to cooperate? The other firm can't punish them anymore, and so there's an incentive to undercut each other at t equals 3. In our example, that meant charging $2. But working backwards, when firms get to t equals 2, they know exactly what's going to happen in the future. They know that there's no more cooperating, and so cooperation is going to fail in t equals 2, and they're going to charge $2 there, undercut instead of choosing $4. Working backwards again, when the firms get to t equals 1, they know that in periods 2 and 3, cooperation is going to break down, and so they're not going to cooperate in period 1 either. And now we go all the way back to the beginning of the game. Both firms realize there's no cooperation to be seen in the future, and so cooperation fails here too. And so when the game has a finite end that both players know in advance, it's impossible to tacitly collude like we did in infinitely repeated games. This phenomenon is known as backward unraveling. In infinitely repeated games, there is no end to the game, so backward unraveling cannot occur. There's always a future in which the other player can be punished for stopping their cooperation. For an application, let's think about quitting a job. The relationship between a worker and their manager is a repeated game of a kind, but one with an uncertain end. The worker and the manager know that their relationship is going to end when one of them quits, but neither of them know when that's going to happen. Because neither player knows when the game is going to end, their relationship is more like an infinitely repeated game than a finitely repeated one with a known end. The worker knows that they're going to be working for this manager for an undetermined amount of time in the future, and so they have an incentive not to shirk. The worker knows that if they shirk now, the manager could fire them in the future. And this incentivizes them to work hard, that's the cooperative action here, to avoid that punishment. However, if the worker announces tomorrow they're going to quit, they've now put a definitive end to the game. The threat of being fired no longer carries any weight because they're going to quit anyway. At this point, they have no incentive to put in any effort on their last day. And so once workers announce that they're going to resign, they can freely shirk without any threat of punishment. So let's think about how the manager can solve this problem. One response would be to fire workers immediately after they announce they're going to quit. This doesn't quite work though, because workers now have an incentive to conceal their intentions to quit until the last minute. This is bad for the manager because now that person immediately quits or is fired, and the manager has to scramble to find somebody to fill the job. They would much rather have some lead time to start hiring someone. A better solution would be for the manager to promise a strong recommendation letter for any worker who works hard all the way till their last day, even after they've announced they're going to quit. This extends the potential punishment for shirking past the quitting date. By extending the relationship between the worker and the manager indefinitely, they've now created an incentive for the worker to work hard all the way to the end. That brings us to the end of our material on repeated games and brings managerial economics to a close. I hope you've learned something useful from this course, and for me, it's a great pleasure and a great privilege to be able to bring this to you. If you have any questions, feel free to let me know. Thanks for watching.